There is one last rule of logarithms that we need to develop. It's called the change of base formula. This is what's going to allow you to calculate any logarithm on a calculator. And so I want to walk you through the formal proof of this. It's really rather short. It's easy to follow. And then we'll do a couple of them. And anyway, so here's the question. How can I calculate the log of x base b if base b is not convenient? For example, if b was 7, you don't have a base 7 logarithm key on your calculator. What we do have is the base 10 log and the natural log keys. So I'm just going to pick on natural log. We could also use the common log base 10. It won't matter. But anyway, here's the idea. I'm going to set this equal to a letter y. And I'm going to change this from logarithm form to exponent form. So in exponential form, this would be b to the y equals x. B to the y equals to x. So I got rid of the logarithm. And now I'm going to use a more convenient logarithm. Let's use natural log. So I'm going to take the natural log of both sides and then use the power rule to bring that y in front. And so this becomes y times the natural log of b equals natural log of x. And I want to solve for y by dividing both sides by natural log b. So y is equal to natural log of x over natural log of b. And that's what we're looking for. We're looking for y. So this gave us a different way of calculating this quantity here. So I'll rewrite this up here. I'm going to replace y with what we came up with. It's the natural log of x over the natural log of b. And I'm going to erase the stuff below it. But anyway, that's the key result we're looking for. We're looking for a different way of calculating this logarithm. And had we done all this stuff by using the base 10 logarithm, then we would have gotten this result. We would have gotten log of x over the log of b. If we use a different base, say a base a, we would have gotten log x base a over log b base a. But basically, the change of base form is only really interesting for us, for the most part, using either of these two logs, since we have calculator keys for those. So this is the change of base formula. Nice to know this one. Change the base. And it doesn't matter if you use log or natural log, you'll get the same result, provided you don't mix them up. Don't put natural log over log. That will screw it up. Okay. So, give you an example. What is the log of 37 base 17? Alright, well, we could calculate this as natural log of 37 over natural log of 17. So, pull out my calculator. And now you might want to try LOG. Log 37 over log 17. Use the common log instead of natural log. And you'll see you'll get the exact same answer I do by using natural log. Alright, so I get about 1.27445 if we round it up to 4 places. Alright, how about one more? What's the log of 3.2 base 0.8. Okay, log of 3.2 base 0.8. Alright, this would be, this time I'll use common log. LOG 3.2 over LOG 0.8. And let's see, log 3.2 divided by log 0.8 is negative 5.2126. So I had to round up to go to 4 places. It's a negative number. And yes, if you took 0.8 and raised it to this negative number, you should get 3.2. Okay, so I'm going to check that. 0.8 raised to that number is 3.2. Good, it worked. So there we go. Now you have a way of calculating every logarithm on a calculator that you need to do. And that could come in handy in solving equations later on. So there you go. Well, one more thing to look at in this section, and we'll go on to the next video.